In this video, we're going to explore using the Linear Regression Shiny app. This app has two sections, much like the others, one for fitting the linear regression model and the other for looking at residual analysis. In this course, we will use both of those components. Just like with the other apps, you have the option of using data from the textbook or entering your own. You could also, if you have your data as a CSV file, upload it. Though for most of us, we'll probably just have it in some type of notebook if we're collecting our own data. For purposes of example, I'm going to go ahead and use data from the textbook, and you could select from a whole list of things that they have here. So I'm going to go ahead and select, let's see, house prices in internet and Facebook. That looks good. So what we can see here is they're comparing the percent of internet use to the percent of Facebook use. And they have a summary statistics option, so that gives us the stuff at the top here under descriptive statistics. It shows us the mean, the standard deviation, etc. And this is based off of, it looks like 32 countries from 2012. In this app, if we scroll down, you see we have the scatter plot here. So this gives us a visual on what to kind of expect. And if you hover over the data pieces, it actually brings you in the spreadsheet itself to those values, so you could see even more information. Down at the bottom, you have the linear regression equation, so you have your slope and intercept. So if you need that for something, then you can create your regression equation. And then the model summary. So this is where you're going to find your correlation coefficient, which describes the strength of the relationship, your coefficient of determination, so that's R squared, and then your residual standard deviation. There's other options of things that you can add here, and that would be on your plot options. You could include the regression line, and you'll notice that regression line is modeled after what you see on the regression equation here. So it gives us the equation, and it shows us what that line of best fit looks like, assuming that a linear regression model is a good fit for this. Some other options you have, you could do the show residuals, and that's going to show you the distance that each data point is away from that line of best fit that we have. You could also include confidence intervals if you're in the later portion of the course, so it's not necessarily something that you need. You could look at predicted values. So if you wanted to type in, let's say, someone with 31, that would be right around here somewhere. It's saying that the predicted value, it's based off what you get in the line, would be 21.504 roughly. So if you look at, we've hovered over that prediction line, that's our regression equation. That's the same value that it's giving us. You could also modify the title and axis labels as needed, right here. Now, if we come up to the residual analysis, this one is going to be based off of whatever you've typed in on the fit linear regression model portion of the app. So you'll notice that this residual plot that's given is based off of the data from here that we've already been looking at. So if you change this data set to something else, you'll see that then the residual analysis will change. So with your residual analysis here, it's the same process. You can hover over things to look at data in more specific pieces. It tells you what the exact residual is, so that means the distance above or below the residual. So that's, remember, your line of best fit. So if it's going through 0, that means that there is no difference from your line of best fit. And this is something you could look to see if there's any patterns with, which would help you decide if a linear model was a good fit or not. Thanks for watching.